Okay, I'm back, and no, we are not back to learning objective number 2. So we're still talking about how can you have volcanoes in the middle of a plate. So if you look at that picture there, look in the Pacific Ocean, and in particular, look at Hawaii. So Hawaii is a string of islands that goes back like this, and then they actually go underwater, and then they go north like this, and then they end up in the Aleutian island chain. So what is it that's causing these islands to form? They're in the middle of the Pacific Plate. So there is no boundaries around them that would be causing all this volcanic action to be occurring at. So what's going on here? So what we think is that Hawaii is over a hotspot. So that there is a long-lived hotspot. It's probably 100 million years old. It's a big blob of magma deep inside the earth that occasionally sends up magma to the surface. And so what happens is the magma comes to the surface and it makes a volcano. But the plate is moving. The Pacific Plate is moving. So that it makes a volcano, but then a few million years later, the plate, because it's moving, here's where the volcano used to be, it moved off the hot spot. So that this volcano over here dies because it no longer has any material coming up underneath it. But a new volcano forms here, underneath where the hot spot currently is located at. But eventually that volcano goes off the hot spot and it dies. So what you end up with is a whole string of volcanoes. Notice the big island. Why is it so big? Because it's currently volcanically active. This volcano over here is dead. And so once something dies, the wind and the waves and the rain begin to erode the volcano down. So you notice that as you go this way, the islands get progressively smaller, and eventually they disappear altogether, but they're still there. It's just that they're under the water. Now, what about this thing right here? So why did it change direction? Now the hot spot, it did not change its position. So the hot spot's always been there, and the plate's been moving across it. So what must have happened? The direction of the plate must have changed. So currently, the Pacific Plate's going in this direction, and it has formed these islands. So in the past, it must have gone this way. So it's an indicator of the change in direction of the Pacific Plate millions of years ago. Now, can you have a hot spot under a continent? So this is a hot spot in the middle of an ocean. Could you have a hot spot underneath a continent? And yes, you can. So let me fast forward through all of this stuff, which we've now gone over. And keep going. There we go. So interplate activity, and yes, you can even have a hot spot underneath a continent, and currently it is underneath Yellowstone National Park in North America. So you have this hot spot, and it sends up material, and Yellowstone is a active volcano. It's not spraying lava and stuff, but it certainly has a lot of heat underneath it because you got the geysers, Old Faithful. So that's telling you it's very hot underneath Yellowstone National Park. It erupts, roughly every 100,000 years or so. It's due to erupt. If you look at that picture there, the picture that shows North America, you'll see a series of dots starting on the coast of the United States and then going progressively inland. And that's it's kind of like the Hawaiian Islands is a chain of volcanoes in the ocean. Well, this is kind of showing the chain of volcanism as it goes across North America. And currently, it's underneath Yellowstone National Park. So what will it look like when Yellowstone erupts? Well, I encourage you to watch this little video here. It's from the movie 2012. And so just go to YouTube and type in Yellowstone eruption, and that's pretty much what it's going to look like. So it's not going to be a gentle event when it erupts. Okay, let's take a break. When we come back, we're just about finished now with this lesson, but let's talk about the different ways that heat can move.